The first thing we want to ask ourselves with Chapter 8 is how is it different from Chapter 7? In Chapter 7, we pretended to know information about the population, like the population proportion and the population mean. And then we learned about the sampling distributions based on that information. In real world, you're probably not going to know that information. Okay, it's very rare that you know any information at all about your population. So in Chapter 8, we're going to take this real-world approach. We're going to say all we have to work with is information about our sample. Okay, based on this information about our sample, how do we go backwards and learn about our population or make estimates about our population? So that's how it's different. So the first thing we're going to talk about is something called a point estimate. And what a point estimate is it's a statistic. And we know that a statistic is just something computed from sample data like X bar or P hat that provides an estimate of a population parameter. Okay, we call it a point estimate because it gives us a single point. Okay, it's a single point that we're working with. And so while that single point is usually not exactly the population parameter we're looking for, it can be reasonably close. And we can use that point, okay, that is our best guess, to create an interval called a confidence interval that we're sure or fairly sure that our parameter lies inside of. So for example, we have to use something called margin of error. If I were to take a sample, let's say I have a population and I want to take a sample of size 16 and I want to find the mean of that size 16. If I look at the sampling distribution, it's full of means. Okay, I've taken as many samples as possible from this population, found the mean of each sample, put them together in their own distribution, and that's the sampling distribution of X bar. Okay, all I know, all the information I have, is about one of these X bars. So maybe this one right here. Okay, but based on the sampling distribution, I know a couple things. I know for one that the mean, the population mean, is here in the middle. Okay, and I know that because I know the population mean is equal to the mean of all the means. So it's here in the middle. Okay, I also know that this is some distance away from that. Because my sampling distribution is approximately normal, okay, I can measure these distances in standard deviations. And I know things like about 95% of my data is within 2 standard deviations. Okay, well if this is within 2 standard deviations, if this is within 2 standard deviations of the mean here, then that means that the mean is within 2 standard deviations of this. So if I start here, I start with my statistic, okay, or I start with my estimate, and I can add and subtract some type of margin of error. And from one point to another, from one endpoint of that margin of error to another, so maybe this is my estimate, and if this way is my margin of error, whatever it may be, this way is my margin of error, then I can find that hopefully the population mean will be in this interval from here to here. That is called a confidence interval. Okay, what's the margin of error based off of? Margin of error is based off of whatever percent we choose that we want to be confident of and standard deviation. That's where this plays in. Our point estimate is our single point. Okay, so let's get an actual definition for a confidence interval. Actual definition for a confidence interval is that it is an interval calculated from sample data and it has this form: estimate plus or minus margin of error. Okay, the confidence level we often refer to as C. It's kind of the symbol, the abbreviation, a capital C. Okay, what it tells us, and it's a percentage that we choose before we ever start working. It's the overall success rate of our method for calculating the confidence interval. So if I want a 95% confidence level, that means I am 95% confident that it's in that interval. 95% confident that I'm right. Okay, margin of error. The margin of error is just how close the estimate is okay, so how close our X bar is to the parameter in repeated random sampling. Okay, notice that this reminds us a lot of the definition for standard deviation. Okay, on standard deviation, the definition is on average, how far away is it from the mean? So margin of error, how close it is to the parameter if we do it a bunch of times. Very, very similar. Okay, very similar to standard deviation. And the reason is because standard deviation plays a large part in calculating the margin of error. So if you go back and look at all the X bars I drew, okay, the only ones that are going to be exactly right are if you get one right on this middle line here. Okay, there's a lot more area, a lot more X bars than just those on the middle line. So why do we include a margin of error? Well, we include a margin of error because our point estimate is hardly ever right just on its own. I mean, if you go back and look, we need the margin of error in order to help us have an interval in which we can work with. Okay, so how do we interpret a confidence level? That's the big thing. You know, interpretation is huge in statistics. So the way that we interpret a confidence level, and we can say this word for word, is that 95, or whatever your C is, percent of all possible samples of the same size from the same population will result in an interval that captures the parameter. Okay, you want to make sure that you talk about this in context. Okay, so you might, if you were given an actual size, maybe instead of saying the same size, say what that is in context. Instead of saying the population, actually give the population in context and actually explain what the parameter is in context. Okay, and don't forget that this is whatever your value of C is. So it's going to change. Okay, then the interval. So to calculate to interpret the confidence interval, we say things like this. We are 95%, and again, this number changes, confident that the interval from blank to blank captures the true parameter. Okay, remember again, this will change. Okay, clearly these will change, and you always want to talk about this one in context. So if we have an example here, according to Gallup.com on August 13, 2010, the 95% confidence interval for the true proportion of Americans who approved of the job Barack Obama was doing as president was 0.44 plus or minus 0.03. Interpret the confidence interval and the confidence level. Okay, so some information that we see that we have here is one, I see that it's 95%, and then I see this. Okay, this I know is my p-hat. That's my estimate because I'm talking about proportions here. Always check and make sure you're talking about proportions or means or something else. So then, since this is my margin of error, right here, to find my interval, I just need to add and subtract it. So my interval would be 0.41 to 0.47. So to interpret those, we interpret the confidence interval by using this right here. Okay, we are 95% confident that the interval from 0.41 to 0.47 captures the true proportion of Americans who approved of the job Barack Obama was doing as president. Okay, for the confidence level, we look up here. 95% of all possible samples of the same size, because we don't know the population or the sample size, from the American population will result in an interval that captures the, and then this in context, true proportion of Americans who approved of the job Barack Obama was doing as president. There you go. Knowing these two sentences right here is very important because you can repeat them verbatim and just plug in the blanks. It's really important because you will be asked, how do I interpret the confidence level? How do I interpret the confidence interval? Those will definitely be questions that you will be asked.